Hi everyone, welcome to helpyourmath.com. My name is Britannia Rose, and today we'll be simplifying square roots with variables. Okay, so let's have our first example. So our first example would be the square root of x to the 6. Now, if we remember, whenever we multiply like variables, we add their exponent. Now, as you can see here, we have 6 as our exponent here. So we can conclude that 6 is equal to 3 plus 3. Now, why we're using 3 plus 3 instead of 4 plus 2 or 2 plus 4 or 1 plus 5 is because whenever we take the square root of a perfect square, we know it's that number times that number. And the same thing applies here. When we take the square root of a variable, it's that variable times the same variable. So we're going to rewrite x to the 6 as x to the third times x to the third. As you can see here, x to the 6 is the product of a perfect square of a variable, because we were multiplying x to the third times x to the third, and whenever we multiply variables, we add their exponent. So to simplify this and to get the square root of x to the 6, we know that whenever we have the same term under the radical in pair, the final answer is just the term itself. So x to the third, the square root of x to the third times x to the third will give us a final answer of x to the third. And that's our final answer. Now, if you were to have, for instance, 4 times x to the square root of 4x to the third. Now here we have 3. Now, we want to rewrite this so we can have an even exponent. Again, the reason why we want to have an even exponent and not an odd exponent is because, like I said, whenever we multiply variables, we add their exponent. And you want to be able to have a number that when it's added to itself gives you an even number, because that's what happens. So we're going to take out an x, and we're going to rewrite this as the square root of 4x squared times x. And we know that x is just x to the first power. So as you can see here, we have an even exponent and we have an odd exponent. So we can take the square root of the even exponent, but not the odd. So x squared. X squared is x times x, which we know the exponent of x is 1. So we can conclude that 2 equals 1 plus 1. So if we were to rewrite this in terms of that exponent, we can rewrite this in the square root of 4 times x times x times x. So we take the square root of this term. First, take the square root of the number, which you know 4 is a perfect square, which is just 2 times 2. So the square root of 4 will give us 2. Now, the square root of x times x, which will form a perfect square of x squared, would just give us x. So, and since x has an odd exponent, we leave it under the radical. So our final answer will be 2x times the square root of x. That's our final answer. Now, if you were to have the square root of 25 times x to the 4th times y to the 6th. Okay, here We have a number in front, so we have to still take the square root of 25. But here we have two different variables now. We have an x and we have a y. Now, since these are two different variables, we can't add their exponents, so we have to keep them separate. So first, let's try to take the square root of x to the fourth. As again, we know 4 is an even number. So we know that two numbers added together, two of the same number added together gives you 4, which would be 2. So 4 equals 2 plus 2. Here for 6. Same thing applies to 6. 6 is an even number. So a number added to itself gave you 6, which is 3. So we know 6 equals 3 plus 3. So we can rewrite this in terms of their exponents. So we're going to rewrite this as the square root of 25 times x squared times y to the third times y to the third over under the radical. So again, now we're going to take the square root of each term. So the square root of 25 would just be 5, because as we know, 5 times 5 gives us 25, and 25 is a perfect square, so we know it's just 5. And then we have the square root of x squared times x squared. Again, when we have a pair of the same term under the square root, it's the square root of that pair is the term. So the square root of x squared times x squared is just x squared. Then the same thing applies to y to the third times y to the third. The square root of that would be y to the third. So our final answer is for the square root of 25 times x to the fourth times y to the sixth is 5x squared y to the third. That's our final answer. Now, let's take the square root of 72 times x to the 11th power y to the 17th. Okay. Here, we see that we have odd numbers in their exponent. So we're going to rewrite this expression in terms of an even exponent and an odd exponent for both variables. And as you remember, since this is x and this is y, they're not the same variable, so we can't multiply these two terms, so we have to keep them separate, and that's how it is. So let's rewrite this as 72 x to the 10th times x times y to the 16 times y. Okay, take the square root of this. Now, we know the square root of 72. 72 is not a perfect square, but we can rewrite it in terms of a perfect square as a product of it. So we can rewrite that as 36 times 2, and rewrite everything as x to the 10th times x times y to the 16 times y. Now, we know 10 and 16 are even numbers. So we know there's a number added to itself gives you 10, and there's a number added to itself gives you 16. And that number will result in the square root of x to the 10 or x to the 16. So let's take the square root of the entire expression. So the square root of 36, we know 36 is the perfect square, which is 6 times 6. So the square root of 36 is just 6. Since we came to the square root of 2, we will leave it under the radical. So our next expression is to go to the square root of 10. We know that 5 plus 5 gives you 10. So we can conclude that the square root of x to the 10th is just x to the 5th. Now, since you can't take the square root of x, we leave it under the radical. So far we have 2 that's left under the radical, and we have x that we left under the radical. The next term we have is y to the 16. We know that 8 plus 8 gives you 16. So we can conclude that the square root of y to the 16 would just be y to the 8th. And since we can't take the square root of y, we'll leave it under the radical. So our final answer for this is 6 times x to the 5th, y to the 8th, times the square root of 2xy. And this is our final answer. Now, like the example said, we have 2 times 48 x to the 7th, y to the 9th, z to the 6th. Now here, as you can see, we have 3 different variables now. And since they're all different, we can't multiply them, so we have to keep them separate. So first thing first, we have 2 odd exponents. So again, rewrite it so we can have a even exponent. So we're going to take out 1. So we're going to rewrite this entire expression as, let's put it down here. So we're going to rewrite this as 2 to the square root of 48 times x to the 6th times x times y to the 8 times y times z to the 6th. Again, now take the square root of each term. 48 is not a perfect square, but we know that a factor of 48 is, so we can rewrite 48 in terms of that factor. So we can have 2 times the square root of 16 times 3 x to the 6th times x times y to the 8th, write that properly, times y times z to the 6th. Okay, so now that we've simplified everything, let's go over here. Now, right here. So this, now our final answer here, we're going to take the square root of each term. So again, put back our 2 because outside the radical. So we're going to have 2 times the square root of 16, which we know is 4, because 4 times 4 gives you 16. So the square root of 16 is 4. We came to the square root of 3, so that would be left under the radical. Our next would be the square root of x to the 6th. Again, 6 is an even number. It can be divisible by 2, which tells us that there's a term when added to itself gives you 6, which we know will be 3. So the square root of x to the 6th is x third. So now we move on to the square root of x, which we cannot take. So we're going to leave that under the radical. The next term will be the square root of y to the 8th. Again, 8 is an even number. It can be divisible by 2, which tells us that there is a number when added to itself gives you 8, which we know is 4. So 4 plus 4 gives you 8. So the square root of y to the 8th is y fourth. So now we're going to take the square root of y. Since we can't take the square root of y, it will be left under the radical. So we're going to go on to our next term, which is the square root of 6. The square root of z to the 6th, rather. Again, 6 is an even number, can be divisible by 2, which tells us that there is a number when added to itself gives you 6, which we know is 3. So the square root of z to the 6th is z to the 3rd power. And that's all going to be times 3xy. So our final answer for this is 8x to the third, y to the fourth, z to the 3 times the square root of 3xy. That's our final answer. Thank you.